I'm Scott DeBlay. I'm Director of Technical Solutions for Compellent.
I'm Craig Miller, Senior Team Lead Infrastructure at VMware. This is basically going to be a summary of what we've been able to do in the last couple of years with VMware and sort of a history of where we've come with infrastructure at VMware. We're going to start off with letting Scott go over some of the really awesome features that Compellent has, because as we'll get into later in the presentation, most of them are really let us do what we need to do and have the flexibility we need. And as you'll see later, gaming is incredibly dynamic. We're changing hundreds of terabytes daily, and things change from day to day. So Scott's got some amazing stuff about that.
Cool. So a little bit about Compellent, and then we'll get into the technology behind it. But Compellent was been around since 2002. Shipped our first product in 2003. Gartner calls us the fastest growing storage company. You can see some of our revenue numbers there. We are a publicly traded company on the New York Stock Exchange. We have over 2,000 customers, over 3,000 systems all over the world. Won a number of awards. And really the magic behind what we do is what we call fluid data architecture. So what is fluid data? To us, it's the ability to be dynamic, to be agile, and to be very resilient in how we manage storage, how we present storage, the capabilities that we provide you. You'll see that throughout here. So what it can do for you, certainly cheaper to operate than a traditional storage array, and we'll talk about some of that as we go forth. We scale on a single platform. We don't have the Model A, Model B, Model C architecture like most of our competition does. We have a very Lego-like approach to building a storage architecture, just the pieces you need today and add into that as you go. And then very secure as far as the capabilities we have, both with local recovery and with replication capabilities. And we'll certainly tie this back into our functionality, how it ties into VMware, obviously, and then Craig's going to go into specifically how he's using it in his environment. So core technologies that Compellent provides, storage virtualization. I use the term that we're the most virtualized storage array that exists from all the components that we do, from the interfaces that we provide to what the servers see. Those are virtual interfaces. Basically, a volume on a Compellent system is a virtual object of storage. To parallel that to VMware, if I go into VMware, right, and create a virtual machine and give a processor and RAM, but actually don't boot the device, I'm not actually using any of the physical resources for that virtual machine. A volume on Compellent is the exact same thing. It's a starting point and an end point to a disk geometry, because that's what a server needs to see, but resources are only used inside that volume as the server writes the disk space. So thin provisioning and all those things we'll talk about take place with the ability to only use what disk space your server is written to. And it's not only about provisioning it thin, it's about maintaining it thin over time. Probably the feature we're best known for is tiered storage, tiering between RAID types and disk types at a block basis inside the volumes themselves. The ability to recover those instantly, the feature called instant replay, map those snapshots or replays that we call back in time wherever you want to go as a read-write instance. And then a very unique feature called live volume, and we're demoing in the booth. I'd certainly love to have you guys stop by and see it, but it's the ability to present shared storage across arrays as a read-write fashion. So if you look at VMware, great technology, certainly VMware clusters typically talking to a common storage array from the aspect of shared storage, so you can do vMotion and all those things. Think of that same functionality, but with actually multiple storage arrays under the covers. So storage virtualization. We take all the drives you have in our system and put them into one big pool of space. That pool of space can be composed of multiple types of storage, everything from SSD to the fiber channel drives to high-speed SAS drives and SATA drives, still in one big virtual pool of storage. We're certainly intelligent about the different attributes of that pool and manage it differently. But parallel to virtual servers, we are taking a bunch of physical servers and bringing them down to a small number of physical infrastructure with a logical infrastructure on top of it. We're doing the same thing in the storage environment. You're not bound by the traditional disk sets and RAID sets and aggregates and all those things that come along with traditional storage environments. You're not bound by a set of disks always has to be one level of RAID, and the complexity of concatenating things together. That doesn't exist in our architecture. Very fluid from the standpoint, again, that one pool exists as a living entity of storage. Thin provisioning, a feature we call dynamic capacity. For us, thin provisioning, the term didn't exist actually when we first started shipping this capability. We've been doing this. Every volume on a Compellent system is thin provisioned. It's just part of what we do. And as I mentioned earlier, basically the idea is that we're only going to allocate storage to that volume as the server writes to that volume. If I go into our system and create a 1 terabyte RAID 10 volume, Obviously, on a traditional system, that would consume 2 terabytes of space. On us, it consumes 0. Server writes 100 gig, I've only used 100 gig. Now, of that 100 gig, if the server actually was writing zeros, we don't write the zeros to disk. In the NTFS world, we can install a little agent, so if I deleted some of that space, I can also give that 100 gig or portions of that 100 gig back to the pool, so I can effectively shrink what's used inside that volume, even though the allocation is the same. We also support the new T10 SBC3 spec, if anybody knows what that is. T10 is what all storage vendors write to for SCSI specs. SBC3 is a SCSI block specification. There's a new function in the newest version of that supports trim. So basically, the operating system asks the storage array, do you support this function? We reply yes, and it says, cool, as I delete space, I'm going to tell you what blocks I don't need anymore, and you can do something unique with them. In our case, we actually recover those blocks. Latest Linux kernel and the Veritas file system support that, and I'm sure other operating systems, VMware and others, will support that in the near future as well. So that's our thin provisioning functionality. Again, 100% of our customers use this because everything we do is thin provisioned. Automated tiered storage, for us, this is, I'll use the term sub-LUN provisioning or block level provisioning. After the volume is presented to the server, we're truly managing everything we do at storage at that block level, at that sub-level, if you will. So when we do tiered storage, what we're doing on a volume-by-volume basis is we're tracking out the normalized I/O of the blocks that consume that volume. So if you will, a histogram of access of all those blocks. Blocks that are heavily accessed, obviously associated with your busy data, stay at the upper tiers of storage. But blocks that aren't busy progress down to lower tiers of storage. You're in control at any time of what levels of storage that server or volume has access to as far as RAID levels and disk tiers, but the movement occurs automatically. So take a look at an Exchange database as an example of this, or any email application, probably associated to one of the more busy applications you have in your environment, because typically everybody's using it. So it has an aspect of performance. It also has an aspect of archiving, in that we all tend to keep a whole lot of stuff in our inbox that isn't necessarily busy today. Yet we tend to architect an application like that completely on Tier 1 storage or fast disk because of the performance aspect it has. What Compellent offers in here is we still present the same LUN, same volume up to your server infrastructure, no agent to install on the server, so nothing's changing from that perspective. I haven't manipulated anything in that environment. But underneath the covers, we're tracking out the blocks that compose that Exchange database. The ones that are busy, and certainly any new writes coming in, remain on top tiers of storage. But all the blocks associated with that database that aren't busy, old attachments, emails, etc., can migrate down to a lower tier of storage. So I could take an Exchange database and probably put 80% or better of it at RAID 6 SATA drives and the rest at high-speed drives. The beauty of it is, though, and we'll marry that into the next feature here, is data that's stored on those lower tiers of drives is read-only data. So I'm using SATA drives for what SATA drives are very good for, storing data that's not necessarily busy, and I don't want to do heavy writes down there, but still intermix it into the entire system. So a feature we call remote instant replay is the ability to separate that read-write environment and provide data protection and recovery protection. So that data that's been progressed down to lower tiers is read-only, all the writes occur at the upper tier. Remote instant replay or data instant replay provides the ability to take the blocks that compose a volume and freeze them as read-only on our system. So we don't have to pre-allocate space for snapshots. I apologize, I've been talking all day in the booth and my voice is shot, but we don't have to pre-allocate space to store snapshots. We don't have the space reservation on a per volume basis. What we allow you to do is take an unlimited number of snapshots or replays on every volume you have on our system at any time interval you'd like them to occur and retain them for as long as you like. So the idea is we take the blocks, freeze them as read-only. Now that's unique in that it doesn't make sense to store even heavily accessed blocks that are read-only blocks at, say, RAID 10. Why not progress those over to RAID 5 or 6, but still within the same tier? And then as those blocks age, progress them down to lower tiers of storage. But because of the way data instant replay works, the ability to recover any one of those points in times is virtually instantaneous, in that I don't have to make a copy of the data. I don't have to put a bunch of pointers together and go to where the pre-allocation space was and build out another volume and use a lot of capacity. All I'm doing is pointing a volume to those objects of storage that you froze in time. So the recovery is instant, and the amount of disk space we use is 0. So look at this from the standpoint of VMware cloning, for example. I could create a volume that has a gold image of a virtual machine or multiple virtual machines, and when I want to deploy that 5, 10, 15, 20 times, All I'm doing is making a view of that initial volume, mapping that up to my VMware infrastructure, and the only amount of disk space I'm going to consume is anything I've made change-wise to those virtual machines. So joining domains, changing IP addresses, whatever it is, it's just that little bit of disk space that's going to change, not an exact clone or duplicate of all the disk behind it. Because of that, it's very, very fast. Now, live volume is a very unique feature. It plays with all the other features I just talked about, including our replication engine, which is called Remote Instant Replay, which is, if you will, traditional replication from a DR standpoint, either synchronous or asynchronous. Some unique features about that is if you're replicating a volume between two of our systems, if you are taking those replays on your source volume, those same replays are replicated to your destination system. So I can get access to data that you're replicating without breaking the mirrors between the two systems. What we're seeing quite common is that people are putting their backup infrastructures off at their remote facilities because due to the nature of replication, you've met the offsite requirement. You're taking snapshots, so you've got your online backups and your offsite backups all in one package, if you will. Now tape becomes more of an archive process, and why not use that remote array to back up your data? It makes a lot of sense. So we layer on top of all that features what we call live volume. And live volume uses replication, it uses snapshots and everything else we do, but it creates the ability for two different storage arrays to present the same volume in a read-write fashion at the same time. So if you will, I could have a 10-node ESX cluster, where typically all 10 nodes would be talking to one storage array. At least talking to one storage array from the access of an individual volume. Certainly could be multiple storage arrays, but that one LUN would be coming from that one storage array. Maybe I want the ability for that 10-node cluster to be stretched across my two buildings in my campus, two different rows in my data center, depending on bandwidth, two different cities within the same state, perhaps. But I still want all 10 nodes to be in one cluster and the ability to do vMotion and those types of things. So that's what live volume gives the ability to do. I could take 5 of those, and from a physical infrastructure standpoint, have all 5 of them talking to one storage array, and the remaining 5 talking to the other storage array, literally separate SAN environments, separate fiber channels, separate iSCSI, whatever I want to connect at. But from the perception of VMware or any other application on top of it, it looks like multiple paths to the same volume. So if you're familiar with MPIO today, you've got multiple paths to a storage array. It looks the exact same way. The difference is those multiple paths are 2 different storage arrays. Now as a vMotion workload from one environment to another environment, I'm literally moving it between physical infrastructures. I'll give you a real-world case environment. We had an issue at our corporate office probably about 3 months ago where we lost one leg of the transformer to our main building. Now, we have 2 buildings in our campus environment. Both of them have generator and data centers and those types of things. So we were fine. We had the one generator running. We have UPS, all the things that you would expect in a data center to have. I'm sure you guys have all that as well. But during the time we had that maintenance window going on, we knew we had to have the electric company come out, pull the transformer, put a new one in. You could argue that we were vulnerable during that point in time for about 6 hours and that we were down to one leg of our redundancy. We have the one generator, should run, but it's, we're relying on that to run for that 6-hour period of time. With live volume, we could take all our physical infrastructure that's running in our one data center and just vMotioned it across the street to the other data center. Everything's running over there with the same redundancies. It still has power from the grid. It still has a generator backup, and done maintenance at the one facility and kept the same level of redundancy. So that's the type of offering that live volume can bring into play, is bring the same functionality of redundancy into play when you have to do maintenance events and those types of things. Cool. Mr. Craig.
Thanks. Take that thing. So, basically, most of that stuff is what I'm living every day. I've been for just over 3 years. Live volume we haven't got to play with yet. The gear showed up on Friday, and I'm here, so I'm not setting it up, but I'm really looking forward to it. We're going to be doing a DR environment in the spring. We'll talk about that a bit. And there's a possibility, this isn't in the slides, of a building move, just sort of continuing on with live volume. If we end up moving buildings, we can just set up a new infrastructure, set up a new cluster and everything, just move all our data over live. We moved buildings about 5 years ago, and we were down for a day and a half. Typical, shut it down, put it in the truck. Everyone's yelling, everything's offline. We were hosting our websites from there at the time, and it's just a major hassle. So that's something I'm really excited into. A little bit about BioWare. We're now part of Electronic Arts about 2 years ago. We've been around for 15 years. I've been at BioWare for 10 years. We've got games in 15 languages. I'm not sure how many countries, but it's in the hundreds. We've been in the fastest growing companies by Profit 100, by Fortune a couple times. So we've had quite a lot of press, quite a lot of uptime, and from an IT perspective, not a lot of money given to IT. Gaming is really there's a lot that goes into it. A lot of money goes into development. Art is getting huge. People are demanding awesome VO, awesome art and stuff, so keeping our cost down is pretty huge. And some of this stuff is VMware specifically, compellent storage. Basically everything we do is in the sake of the dollar, so we can hire more people to make better games. So just over a year ago, we didn't have any VMware. We didn't have any virtualization. We looked and dabbled with VMware Server and ESX 3.5 and stuff, but it wasn't quite ready for us. When 4 came out, we started playing around again, like, hey, let's check it out. We now have about half, just a couple of VMs, under half, completely virtualized. And I got a goal that I want, by the end of this fiscal year for EA is end of March, I want everything to be virtualized. And that's minus firewalls and a couple things that I could consider still need to be physical devices, but 99.99% of servers or anything that the end user will see, anything that our online websites are serving to developers is going to be virtualized. And that's a pretty quick transition, considering the amount of data we have. We currently have about 200 terabytes of data, and things are iterating over and over and over and over and over, especially in the last 3 or 4 months of a project. We might see like 20, 30 terabytes of data change per day. It's not new data, but it's overwritten and overwritten and overwritten. So being able to move into VMware has just been a real win for us. Basically, my phrase I've been saying is that VMware lets me keep my butt in my chair for as long as possible, and it's really true. So a bit of the challenges about BioWare and pretty much any game company. The cinematic quality, art, animation, audio, everything's now voice-overed and lip-synced, and just a huge amount of data. And we're talking about VO for a game is hundreds of gigs before it is compressed down. I guess a good example, a single Blu-ray, double-layer Blu-ray that'll ship for the PS3, in production, it's in that 100 to 200 gig range for the game. We got to get, 100 to 200 terabyte range. We got to get that down to 50 gig to ship it on the disk. So the amount of disk data we have is completely huge. We still have some disparate disk that we haven't moved into our SAN, which pains me. But I mean, we're talking about we're talking about a lot of data. So we're talking about just a huge amount of data. We got audio and 4, 5, 6, 20 different versions of audio, and same thing with animations and cutscenes and just a surreal amount of data. And to make it worse, we have for BioWare Edmonton is where I work. We have about 50 people working in Montreal. On the same projects, specifically mostly Mass Effect. And most of the data is in Montreal, is in Edmonton. We have replication of the data in Montreal for certain things, but the way the game tool sets work, we have a single SQL database that has most of the content and most of the designer data that is changing on the hour. And those guys need to be working on the data. So keeping that up and running and sending VMs around is really hugely important. Intellectual property, that's all BioWare has. I mean, we have some amazing talent, don't get me wrong, but if our systems aren't up, people can't work on that data, can't reference old data, we pretty much got nothing. So archiving is really huge for us, keeping things online. Someone deleted something from one of our first games, MDK2, sometime. Just this last spring, someone asked us to restore it. Hey, we need that. We need this sound clip from there. And we had to go back to the last time we'd seen it. It was deleted sometime in 2001. And getting that back was a challenge, but things like that just reaffirm the thing that we need to have everything online all the time, whether or not it's accessed every day or not. And that's pretty much 24/7 ability. One thing about gaming, most companies have a nice outage window, maybe on a weekend. You can shut things down for, let's say, Saturday afternoon or something, or maybe done on Sunday. As soon as the developers and artists guys go home, that's when their scripts and their processes start to really work on the data and grind it so that hopefully by the next morning everyone has a new build of the game to update so they can keep on doing their job. So my outage window is 6 p.m. to 8 p.m. on Wednesdays. And that's it. And I need a week's notice. I have to give people a week's notice if I'm taking down anything and actually get it approved if I can do it in that time. So I've been really happy with VMware in there. I mean, it's just I giggle every time because last week we just added 120 gig of RAM to our VMware cluster in the middle of the day. Getting that kind of outage to do that on physical servers would have just been awful. Well, in fact, it wouldn't have happened. We had servers that we hadn't touched for years until something happened to them, and then you hope they boot, right? And things change. I've been here for 2 days. I'll get back on Friday. I have no idea what new requests are going to have come in. I got some numbers in here on how many VMs we had on Friday. That's probably not true anymore. There's probably 15 or 20 production servers running that my team set up already since I've been gone. And things change, and someday someone might need, let's say, 2 terabytes or 3 terabytes for a VO application. This is an example from a couple days ago. And they say, yeah, okay, we need 1 VM to process this, and they start running on it, and a couple days later, it's not working very well, not very fast. Well, they find out it's only a single-threaded application. Okay, we need 3 VMs, and that same data replicated to all of them. And then the next day, no word of a lie, we're like, well, we got a patch from the vendor, and now we just need the one back again. So thanks, but that was a waste of time. So stuff like that is just, everything happens so quickly, and having what we've done with VMware is just huge. We were up to 4.1 completely 2 weeks after it was out, primarily for storage I/O control. It was, we have so many data stores and so many VMs across all the hosts and things moving around all the time that I just needed that. One feature made me just basically jump on the bandwagon, and it's been working great. So I've talked a little bit about this stuff already. Scalable dynamic is BioWare. I mean, things change so quickly. We need storage that's great. We need networking that's great. We've just upgraded our network at the end of June to basically we're running 10 gig pretty much everywhere on the back end, bonded 20, 40 gig. Each of our hosts has 2 20 gig connections to the front end. 2 10 gig connections to the front end. 2 10 gig iSCSI connections to the storage will be added next week. And they each right now have 2 4 gig fiber channel connections that we're actually going to be ripping out in a couple months and going 100% iSCSI. And the main reason for that, well, there's a bunch of reasons for that. Cost's one of the big reasons, but as you guys probably know, VMware has a 2 terabyte minus 512 byte limit that you can pass through as an RDM or as a data store, and that pains me. VMware knows that pains me, but BioWare has more than half our LUNs are over 2 terabytes, so I could map multiple LUNs, create multiple 2 terabyte disks, but then I'm still having the OS, whether it's Linux with LVM or Windows spanning drives. The complexity is just not there. So we're going to be passing these LUNs right through with iSCSI right to the guest, as well as the boot drives with iSCSI into data stores, and that's going to be super cool. What else? Automation. We're doing right now we're scripting a lot of the back-end creation of data stores and stuff, and I like it. What these guys showed me here yesterday that I need to have is the new VMware plugin from Compellent. Basically, just right now it's taking me about an hour, let's say, to add a host. We'll get into this. I got 11 hosts right now. In July we had 4, and probably by March I'd imagine we're going to have in the range of 30 to 35. Don't quote me. Basically adding all the mappings, creating the data center, creating the data store, making sure it's all on everything. I've been scripting. Now it's basically a right click and an add and a couple next screens, and it does it all for me in about 2 minutes. And I wish I could show you, but I just saw it for the first time yesterday, and it's badass. Pin snapshots. We snapshot stuff differently depending on the stage of the game. So we're coming into the Christmas season. Probably in the next month we're going to be getting into a crunch where guys will be at work from 6 in the morning till midnight and stuff processing all the time. We'll be snapshotting these things, I would say every 5 minutes for some of the key things. Right now we're only snapshotting stuff twice a day. And it's at the same time when things come back to the end of the project where one little mistake, someone deletes something or someone worse corrupts something, uploads something that screws up somebody else, that he runs something that screws up all these people. Rolling back, being able to roll back from the VMware side, go back to an old LUN, whether it's 5 minutes or an hour or a day ago, and mount that and view it is something I'm really looking forward to with this new VMware plugin too. So here's what we got. We still have 90 physical servers. We've gotten rid of almost 100 in the last, well, it's been about 9 months. We're completely up to vSphere 4.1, which I've been criticized a lot that we were that quick, but storage I/O control was huge for me. We're going to be implementing network I/O control pretty soon. Though with 20 gig of Ethernet per host, we're not really running into that yet, but by the time we're done moving our file servers and our Perforce servers into it, I think we're going to be pushing the bandwidth of some of these hosts. So network I/O control will be huge too. So we got 85 VMs running across 11 machines. Most of them are Nehalems. 4 of them are the next gen. Each with, 120 gig of RAM in each host. And 92 vCPUs, which is it's just super cool. I don't know, I just love VMware. And you guys are here, so I assume you guys love it too. Our storage, we got 200 terabyte of active data, 2 trays of 2 terabyte data sitting dark in my shelf right now that I am just excited for next week to light it up. And the growth, I pulled that number, just sort of guessed at that number. It's probably, I would say it's a little bit over 40%. How much, just on the amount of disk we're buying. Things are just, games these days are just getting bigger and bigger and bigger. And the next gen, I don't even know how we're going to keep up with it. The next gen, like the Xbox 720 coming out in a couple of years, is going to be 1080p, and that's just twice as much data we're going to need to host. So we got 10 trays of 15K and 14 of 7.2, 16 actually, if you count the two that are there. And we've been buying probably back and forth, 1-to-1 almost, a couple more trays of 7.2 initially. But because, like I was saying, we have so much data changing every day that we buy a lot of 15K disk, which is I think out of the norm. I think that with the data progression stuff, people are using more SATA overall. Absolutely. But we're moving stuff down, we're archiving stuff. One of the cool things, and hopefully it's on this side, and it's not, but that's okay. At the end of a project, like all that 100 terabytes needs to get active or needs to get archived if it's on disparate disk or if it's on our SAN. It needs to happen in a very short amount of time. So if it's just a file server volume, which most of the stuff hasn't been touched in a while, we need to basically not even just take a snapshot of that, but process it, either migrate into a database, or we have an archiving, VMware has an archiving application to basically take a copy of all the data in the way it is and make it referenceable in the tool. So it's not just a snapshot of the same volume. It's kind of worse than that. It's how do I say? It's more basically it's a copy of the data. During the course of the project, a lot of that data hasn't been changed. It's been down to tier 3. Maybe it's on to disparate disk. We need to move that really quickly, and that's what a lot of this fast disk is for too. We have maybe a week to let's call it archive all this data. It's still online. It has to be online 24/7, but it's not being actively changed. Though it's definitely not. It's far from read-only. And moving that, we basically bring that up into 15K disk in a couple clicks, and all the writes go there, and then we can actually set it to just be in tier 3, just so that if someone does accidentally point a tool at the wrong place, it doesn't fill up our fast disk, which happens almost daily anyway. So we eliminated 100 physical servers. We had a planned expansion of air conditioning this year. We got 2 10-ton Liebert units in our data center that are oversubscribed. We can barely run on one. So we had a big expense planned in the budget to do it. Because of VMware and how much stuff we've actually been able to P2V, we're not doing it. And that was about $80,000, and that money went right into more hosts. Which even helped even more. I get a lot of flack from this too, but we're booting all our VMware ESXi from SD cards. It's a religious debate. Do you boot from SAN or not? Do you...
You have one fan.
Whatever.
Saw a thumbs up on one of those.
But I love it. A lot of the people I talk to are booting from SAN. As I mentioned earlier, we're going to iSCSI. We're not going the iSCSI dedicated HBA method, so I won't be able to boot from iSCSI on the SAN. But setting up a new vMachine host from an SD card is minutes. It takes longer to set up the Dell D-Rack than it does to get VMware installed.
How many of you guys are running iSCSI today, or going to be? Pretty good chunk. Are you running fiber channel today and moving to it, or is it new? Yeah, fiber channel today and moving. Otherwise, the rest of you are new looking at iSCSI.
Yeah. If you have any questions about iSCSI, definitely ask away. I've done a lot of research. We've been running 1 gig iSCSI multipath to 2 and 4 gig for just over 3 years, and it's definitely production ready. And we're getting rid of fiber channel for it, just for the cost and the flexibility. And I'm super excited. What else are we doing? So one of the big things that I've been talking about the last couple of days, and I talked to a lot of people about why we're using Compellent, especially in EA. We got a lot of the different studios. Why am I using Compellent? Well, things are done in such a way that it just allows for a lot of flexibility. I'm getting some echo now. One of the big things that I asked these guys is, when I was looking at something, this thing has to be online 24/7 forever. All upgrades, big upgrades, whatever it has to be, it's got to be online, because VMware won't give me an outage window. If it's down for 6 hours because of an upgrade or whatever, it's just not going to happen. So we're 3 years. We haven't had an outage, except for power. Edmonton's a really bad city. We got 5 minutes of a power outage, or it seems like a day or a day and a half. And sadly, we've had 2 of those. And one time the generator didn't fire up. Such is life. But the thing I would really wanted to talk about in this slide is the no volume pre-allocation. So in VMware, we're not using thin provisioning in VMware. We tried it, and we actually confused ourselves that, you can create a bunch of 500 gig data stores and you fill them up from one or two one or two VMs, and it's just sort of something else you have to keep an eye on as far as you can get reports for which one's going to fill up. But we've chosen to thick allocate on the VMware side, just because we're lazy for the most part. We got 3 guys for all this stuff and the network and fixing the sync and a bunch of other good fun stuff. So having the fact that thin provisioning is sort of always on just lets me do that and not have to worry about getting reports from VMware. Is my volume almost up? We just never have to run with that, or never have to run into that problem. And this 5 minutes for a new volume with a new plugin it's literally 30 seconds. I wish I could change that. So I talked a bit about this sort of in the archiving when we're migrating stuff. The automated tier storage lets us not even think about it. We just write stuff. It goes to specifically the outermost tracks of RAID 10 on the fast disk, and it's just there. I never ever think about moving it down. Never think about pretty much anything except just firing the data there, and if it's not being used, it's going to be on the slower disk. And pretty much just our archive stuff's on slower disk. Everything that BioWare does is on fast disk. It's changing every day. Some of these volumes that are, like our big Perforce server, is in the 20 terabyte range in a single volume. How much it's changing a day fluctuates, but it's in the range of a couple hundred gig just on that one server. And it's not new adds, it's updates to the exact same code and same art and same audio over and over and over and over and over. So that stuff, that server's not tearing down very much. But I never have to set anything about it. It just does it.
So Craig, what's an average volume size you deploy in your VMware environment?
Well, so for the VMware boot servers, the C drives, the OS is 500 gig. We're trying to keep to about 8 to 10 VMs per data store. As far as the actual data, the average size is probably closer to 10 terabytes, which is why I was mentioning we can't live with the VMware 2 terabyte limit. It's crippling. I mean, we have a couple which we passed through a couple different extents and then added them together in Windows, and it's good, but passing it in directly with iSCSI is a single run that can be extended anytime, and it'll be much happier.
So when you look at that 500 gig volume you created that has your boot volumes on it, C drives, did you say? Mm-hmm. What percentage of that is on high-speed disk versus slow disk when you look at the interface?
It's a good question, and I should know that. But I don't know that I can make a very educated guess that the C drives are not touched very often. I mean, the swap file is there, but for the most part, it's probably like 80-90% tiered down. The reason I don't know it,
it's actually a good answer that you don't know.
Is because I never get in there.
You don't have to think about it.
I'm
it's
never
just doing
in there.
It automatically for you. Yeah.
And I mean, for the Storage Center GUI guys, with that new VMware plugin, I'm not going to be in there at all. So I'm going to have to apologize to them because I'm never going to look at it anymore.
But that's pretty good if you're managing 200 terabytes of active data and you're not looking at it to see what's going on because you don't have to. That's mm-hmm. Pretty impressive.
Yeah. Well, yeah. I don't have the manpower. Like I said, there's 3 of us for everything, right from running all the websites to basically BioWare infrastructure is responsible for the facility up to the application running on the machine. So if it's like a SQL server, we're running and managing SQL Server, then there's a DBA making databases. But all the OSs, all the main applications, we're responsible for. So it's Things like this, things like VMware, things like Compellent, just set it and forget it. That copyright? So another thing that I learned yesterday, recovering data. We do it, I wouldn't say we do it often because hopefully people don't delete stuff very often, but I'd say every couple of weeks we have to roll back a VM, mount it up just to get data and just to test that we can. Roll back from a snapshot on the SAN. We test rolling back from archive from our virtual tape library less often, because hopefully we don't have to go to that very often. We haven't had a building fire yet, so let's hope that stays that way. But recovering from a VM, basically a LUN, like I was saying, 8 to 10 VMs per LUN, we'd recover that LUN and reconnect it to VMware. Scott now has in that plugin, it's a right-click, recover. You pick your snapshot and you're done, and it's there, and then you can just start your VM up. And it's really that simple. It's about a 2-minute process, and it's done. Right now, we're doing it with a couple scripts and a couple CLI commands in VMware, and it's maybe 15 minutes, which isn't bad, but this is just, like I say, letting me keep my butt in my chair more often. Hopefully not working myself out of a job. Next year, we're talking about a big offsite DR. We've been doing a really good job at onsite DR, basically keeping these things, keeping our developers running, keeping things chewing in overnight if something goes down. Moving to VMware is what we've chosen to do, to not have physical hosts. I mean, if a physical host with a whole bunch of data assigned to it and a bunch of hardware goes down, it could be a few hours, best case, to get the hardware fixed or get a new hardware in there, remap the LUNs, reset it up. What we're going to be doing with VMware, continuing that, is saves us time. Just basically, okay, so this host died, this physical machine died, who cares? It's going to get fired up over there. We have a couple things running in fault tolerance, but until it comes out into multi-core, we're not going to really embrace that. So next year we're going to be looking at an offsite DR. We're replicating archive like virtual tape libraries to our other site in Austin right now, but as you know, it's tape, so you're going back to a backup recovery software. You have to restore the files, restore the databases, recreate the stuff. It's okay for looking back in time to find files from games that shipped in 1995, but it's not so good when the building burns down. Or you have something catastrophic, a water leak or a power outage or whatever. So we're doing a big initiative to get another, basically another VMware cluster, Site Recovery Manager, getting in so we can have that up and running, and also look at maybe having some live applications served out of there, load balancing our online websites from both sites. Basically with the live volume, which is something I hadn't thought about until just yesterday. Basically, we can have our online web server, www.bioware.com, is still served from our Bioware data center. If we can have that at both places, the local guys can develop and do all their content changes to what they think is local, and the websites somewhere else can think that they're local because they're writing to the same database, or at least they think they are. The data is identical in the back end, so I'm really excited about that.
How many of you guys look at, when you look at DR, consider on-site versus off-site DR? How about you consider just DR off-site all the time? Just curious. So is on-site more HA, from a terminology standpoint? Okay.
So yeah, secondary SAN, all SATA. It says 10 gig. I really don't think we're going to get 10 gig within the city from any ISP, so I think that's a typo. But we'll be looking at hopefully a couple gig at least, just to keep things replicated up to date as much as we can. But in the case of a major catastrophic failure, even if we're looking at a couple hours behind, it's better than weeks right now to recover the data from VTL.
I'm kind of bummed out now. I thought you were going to run a 10 gig WAN.
Well, you going to pay?
I'm not going to pay.
Well, then it's probably not going to happen. Yeah. You want to go over some of this here?
Sure. So, you look at features like thin provisioning and tiering, replication, and all those things. In order to effectively manage anybody's storage environment, you need the tools in front of you and the data in front of you to know what's going on. You look back at the early days of thin provisioning example. That was one of the complaints most people had with thin provisioning is, I get it, it makes some sense, but here's one more piece of information I don't have to really see what capacity is being used. I mean, my array doesn't report to me now what's being used, so if I over-provision it, I'm going to run into a potential problem. But one of the things we do at Compellent is make sure that you have, probably in some cases, more information than you could ever want to see exactly what's going on. We have a tool called Enterprise Manager, which rolls the management of a single array or multiple arrays all into one interface, whether those are in one data center or across the world. Threshold alerts, so you can set alerts to say, I've architected my storage environment to do 20,000 IOPS per second. So if it's running at 22,000 IOPS for 15 minutes or more, I want to know because I'm starting to exceed what my design was built for. If my capacity gets exceeded, if my latency gets exceeded on an overall system basis or a per volume basis. I want to see exactly what my storage consumption has looked like on my various tiers of storage for the last year or the last 2 weeks or whatever the case may be. So there's a lot of robust reporting infrastructure and detailed view of what's happening with there, including things like chargeback. Even for those of you who may not actually charge departments, the ability to define a dollar amount per gig or per RAID level disk type so you can see to your management, here's what actual storage is costing us from this environment, including the energy costs associated with that. In our interface, you put in what your dollar per kilowatt is in your environment, kilowatt hour, and then we'll tell you what the energy consumption has been, how much CO2 that is equated to. So you have all these reports in front of you to be very intelligent about how the storage environment is operating, and then be selective on what needs to change, if something needs to change.
Mm-hmm. Yeah, I'll let you do that because, it's another tool that I use when I need to, and I probably should use it more, but Compellent and VMware are two things that I don't think about, which is good. Recently, we've been worrying about, we had some contractors working on our adjacent hotel, and they wrecked one of our AC units. And so I got to deal with crap like that most of the time. It's good that this stuff just works. So what have we gotten out of all this? Primarily, the last year has been huge with VMware. We've been a Compellent client for 3 years, and we love it. VMware is really giving us the ability to save power and cooling. Is one of the big things. Extend the life of hardware. One can argue that hardware changes so quickly that we'll be upgrading anyway, and we probably will. But we have a couple hosts in our cluster that are a couple years old, and they're doing good. They weren't able to keep up with the needs of the applications they were running with bare metal, but by sticking VMware on it, VMware automatically moves some systems onto it which don't need as much RAM or as much processing power, and we're still able to use them. Deferring purchase of additional storage is, for the most part, I would say yes. BioWare uses a lot of storage anyway, so I haven't done the numbers in a while of how much data we'd actually have to have if we didn't have, or if we had to have more fast disk in our array because of no automated tiering. But we definitely have to buy a lot more. But we do buy a lot anyway. Administration time is huge. vSphere 4 is huge. 4.1 is better. I can't wait to see what VMware is going to come up with in 5 and in 8 and whatever's coming up. It's just going to be super slick. We have ultra efficient IT staff, and let's say that's a scam because I don't think I'm that efficient. I'm using all these tools really well, but the tools are helping all of us. A year ago, everything was manual in our data center. Everything was physical, fiber channel everywhere. Now, I mean, those of you who are living this know us too. Is just you want to move a host from one cabinet to another or whatever, you just put it into maintenance mode. 30 seconds, maybe a minute max later, there's nothing running on anymore, you go shut it off. And I'm really excited about multi-core fault tolerance for that too, and then just not even having to worry about sort of basically any downtime. And getting data back faster. That's something which I had an idea what was to me. And then, like I said, Scott showed me this new plugin that isn't out today, maybe next month or something, month after. But I want it today. It's one of those things. It's going to save me so much time. What are we doing next? We are doing a couple big tests. We have huge build environments. Basically, all that data which gets processed every day is run across dozens of systems, 8 cores in each system, maxing them out, like hundreds of gigs of RAMs across, let's say, 20 systems. And moving those into VMware, they have to be at least as fast, the applications. I know that with the testing we've done, they're going to be faster, mainly in the I/O control, with or without storage I/O control. We found that VMware's I/O scheduling is just more efficient than Windows or even Linux. Even how much you can tune Linux. All of our VMware VMs running Linux, the I/O scheduling on all those, we changed to Noop, and things are running better than we could possibly tune them straight on bare metal. And then one thing which I'd hope to have in here, it didn't come around, we're going to be virtualing a product called Perforce, which is our source control program that most companies are using. VMware, actually, I've been talking with them because they use Perforce internally for their own code. And some of their big Perforce environments are not virtualized. And I wanted to find out why. Perforce doesn't really recommend it. I said to hell with them, and we've done it. We're testing it, and as soon as we get up to 10 gig iSCSI where I can pass these 20 plus terabyte volumes right through to the guest, we're going to do it. They're going to be tied to specific hosts. Like each of these VMs will have 64 gig of RAM in them. So we'll have a couple of the VMware rules. Just make sure that that they aren't moved around too much, that they get as much physical resources as possible. But the ability to move these things from host to host is just going to be a huge. When we have these Perforce servers specifically cannot be down ever, and if they are down, none of the internal servers work, none of the tools work. People can't do anything at BioWare. So getting that from a multi-hour outage, if something happens, to a couple minutes, and with multi-core fault tolerance, which I'm riding VMware on, there may not be an outage. Just on these super critical things like our Perforce, we just need it to be up all the time.
How many of you, just ask one more question, are hitting the VMware 2 terabyte limit and getting annoyed by it? A few of you?
A couple.
How many of you thought about doing iSCSI inside the guest as a way to get around? Same ones?
Yeah.
It's a neat way to go.
Yeah, if you haven't run into the 2 terabyte limit, if you ever do, it's something to think about beforehand, because you just, unless you're familiar with spanning LUNs already, it's pretty easy in Linux with LVM or Windows with basically just disk span, and you know about all the ins and outs and how to bring a LUN back and how do you snapshot that LUN across at the exact same time on both of them without impacting the server for several seconds. Think about that 2 terabyte limit, because until it goes away, it's a hard stop. Because I refuse to move some production servers like VMware. I mean, like Perforce, having those multiple extents together, or having it RDM with having the host pass through multiple like RDM data stores, and then having LVM put them together. It's just too complicated. So that 2 terabyte limit, I really hope will go away soon, but it's not on the roadmap. So I'm looking at it a different way, and we're doing it a different way, and I'm really happy about it. The next thing on our list for infrastructure, maybe a year and a half out, is virtualizing network ports. We want to get away from spanning tree completely, and basically increase our network uptime. We've done a good job with virtualization and storage to have super uptime. We're having some problems with spanning tree in our environment.
No.
One of the big problems, so we have all these developers, let's say an Xbox, a PS3, 2 computers, and a phone plugged into the network. That's a lot of ports. So a lot of the guys have little 8-port switches. And we have to have spanning tree on in such a way that it is so picky about what ports come active on the switches, just in case 2 of them get together and plug in every port to each other, and then plug them all into the wall and just bring down our whole network, which has happened.
Who knew that Netgear was an enterprise storage
Hey.
or enterprise network device?
That's what we're using. But yeah, so we're running spanning tree really heavily. I've got a couple blog posts about how spanning tree has killed us, specifically with a switch that we had no business using as our core network switch. But we were, and that's fine.
D-Link?
No, not D-Link. No. Another D word, though.
Sorry for anybody who works at D-Link.
But basically, if we can get rid of spanning tree, but allow us to do aggregate links and do multiple linking and failover without spanning tree, there's a couple options. Cisco's working on something, Brocade's working on something, and we're talking with anybody we can to just sort of tackle that next problem, because the VMware's made it pretty easy on the physical server side. So that's what's up next. Game over, but it's more to be continued. I mean, we did that. That was cool. That's what I do. What I'm really interested in is what questions do you have of me, because we do a lot of cool things, and that's. So if you have a question, go up to the mic, please. We've been asked to do that. What do you want to know about BioWare?
You mentioned a couple of separate risk factors. One, you're virtualizing fairly rapidly. I mean, you started in March 2009. You're up to 50% now.
Yeah.
And at the same time, you have about a 40% growth rate that you estimated.
Yeah.
Did you run into any growing pains or any stress factors during your growth period?
Yes. One was a 2 terabyte limit. We started off with all the easy ones, all the low-hanging fruit, domain controllers, little application servers, license servers, all this stuff. And then, let's test out a file server, because we could use some more performance. Oh, I can't. Well, that's not cool. And that derailed me for a couple days, trying to figure out what we could do. And we stopped doing that because our current option today would be multipathing up to 4 gigabit iSCSI. It's just not that great right now when the hosts, those physical machines, file servers are giving out. They have two 10 gig connections to them, so 4 gig storage, it's just not enough. That was one of the big growing pains. Another one was the first bunch of hosts and guests that we did were high RAM usage ones. We didn't really spend a lot of pre-time looking at difference between RAM and CPU load on some of these servers. We just started doing all the ones we could do easily first, either without outage, or they were maybe be more idle, or we could just sort of do them, because if they were, like, let's say a web server, well, we have 3 or 4 web servers, we can do one at a time behind the load balancer, and then one node at a time. we brought our load balancers into VMware, and most of those were all high RAM usage, but not a lot of CPU. And then we started getting into some of the more build side stuff, processing stuff, and they started using just a heck of a lot of CPU and maxing out a cluster. So we started throwing hosts at it. We just last couple of weeks we upgraded RAM, and we're just throwing resources at it. So yes, and we're going to have more, but that's part of the fun.
Hello there. You mentioned Perforce a few times.
Yeah.
And I've never heard of anybody actually running Perforce on VMware, so I'm a little curious as to what the onus was behind making that decision, and any drawbacks that you may have seen to that, any benefits. And in particular, you mentioned the snapshotting. I'm kind of curious if you ever exercise that function. How do you keep your clients from getting out of sync if your database rolls back?
So let's start with the last one first because it's the easiest one, and we just we can't roll stuff back from the production side. We can roll back to a snapshot and bring the data over. We've never rolled back and actually represented a LUN and said, hey, okay, this is back 3 hours, or roll back a snapshot of a VM. It would throw off our process by days and days and days, and tools would be broken and things, because every day, today's build, and even sometimes multiple builds per day, the data from yesterday can't be read by the tools anymore, because the tools right up until the end, all the internal tools for design and for the layouts and the levels and everything are also being iterated on. So every day, all the resources are rebuilt because the tools are rebuilt and they just don't match up. And the first question, what was the first question again? Sorry.
Why did you virtualize?
Perforce?
Oh, why Perforce? Why is nobody doing Perforce, or why are we doing Perforce?
Why are you doing Perforce on VMware?
Right. So.
I've never heard that before.
Yeah. So we're doing it on VMware because we want more uptime. We do want more performance. Our testing on the same hardware, identical systems, same amount of RAM, same LUNs. Just putting the VMware shim in there, it's running faster, which is, from everything else we've experienced, that's the norm. I mean, we've got a heck of a lot of time into tuning Linux specifically for Perforce. We're running ext4 already for Perforce, which is it's not ready, but we need the performance. So on top of performance, adding the uptime. Basically, if something goes down in the middle of the night, it's always the worst time. Middle of the night, long weekend, like we're coming up with right now. Our build processes don't take off any time. If the host goes down and VMware can bring it up automatically in 5 minutes, and I can keep on sleeping, that'd be pretty good. Time?
You had a quick question, I think.
Kind of a game industry thing. Are you involved in the infrastructure for the Old Republic, or is that handled outside?
Let's say yes. Yes in both aspects. I'm working with them. I'm not responsible for it. I think the better, because that's a huge undertaking.
Oh yeah.
But I'm definitely working with them. They weren't virtualizing anything a couple months ago. Now they're doing a heck of a lot of stuff. I got some time afterwards if you wanna talk about it too.
We can get your roof real fast before they kick us out of here.
It's an easy one. How long have you been using Compellent? How long did it take you to deploy it initially, and what were you using for storage before?
Sure. So before, we were using awful storage, disparate internal disk across multiple servers. We are what? I guess we're 3.5 years into it. Would have been May, 3.5 years, or 3 years ago, May. And the initial setup time was like a couple hours. I mean, racking it took longer than we're making our first volume and mapping it in less time than it took to map it. And that's pretty much what we're living day to day to day to day to day. We get new disk. I do it in the evening. I add new stuff in the evening just in case, but nothing's ever gone down in 3 years. So it just keeps running. Just keep.
Thank you.